I've started about 2-3 minutes early, so I'm just going to talk for 2-3 minutes before we get on there. So we're going to discuss DILR. We're going to discuss DILR slot 1, which happened in CAT 2017. Got a couple of fabulous sets. I really love this. I took the CAT for slot 2 in 2017. So I had a lot of fun and trying to crack these sessions this time around. So I had a lot of fun doing this. So there's something very intriguing about this, some pattern that I could kind of tease out of this, of trying to solve them now. They're very. There's something numerical to a bunch of these sets, which is very exciting. So I've been asked a bunch of questions about how to prepare for DILR. So before we hit 10 o'clock, I'm going to have a chat about that. For DILR, do some basics. Get your hands on your mind moving by doing a bunch of questions on standard bar graphs, column graphs, line graphs, charts, sequence puzzles, arrangement puzzles, and your conventional puzzles, which have not really appeared in CAT 2016 or 17, 15 before that. But get that flow. It's very tough to jump into something really difficult without doing the grind. Do the grind. Your first half of the preparation for DILR is going to be the grind. Getting used to the idea of percentages, percentage increase, percentage decrease, shares, analyzing degree in a pie chart, growth rate, having a sense of it from that. And then move on to unconventional puzzles. See as many different puzzles as possible, and so that you get better at cracking a new one. And so there's one school of thought which says if all puzzles are different, what is the point preparing? That is humbug. You do 25 different puzzles, you become really good at cracking the 26th one. So train yourself for that. And so it is very useful to prepare from different atypical puzzles. And so make sure you do that. Where should you start preparing? Of course, 2IIM. Why would you not pick 2IIM? So do that. Go through whatever is freely available from 2IIM. But that apart, the mothership for preparing, if you ask me, is CAT 2017 paper. They've handed it on a platter and said, look, these are the kind of questions that we like. This is what we're looking for. We're trying to say that we're looking for something slightly different in DILR, and this is that slightly different. So communicating that. The CAT 2017 actual paper is a brilliant place to start. So keep that as a good starting point when you're beginning your preparation. Second thing I've noticed is a lot of people say, look, the puzzle is good, challenging. I'm either able to crack it or I'm out of it. I don't understand anything about it. I get jack about it. And so this is precisely for this category where the preparation help could be very useful. You could take somebody else's input and do that. In that, place enormous stress on solutions. You will need to think of some of these constraints and criteria, like the way the guys who designed the puzzle or the guys who cracked the puzzle, they have thought about it. They are seeing something in one small, tiny criterion that you missed out. And so you have to gear yourself to be able to pick that tiny trap in that criterion next time around. It really helps. We did not have the luxury of getting into somebody else's head while we were learning. We were given a paper and you would solve it. You got it, you didn't get it. The next time around, you naturally got better. But I could ask my friend how he or she cracked it. But getting one input from someone who's in the same boat as I am in, probably he's also skipped that question. So you guys have the chance to because there's so much is available online, to get into the skin of somebody who's designed that puzzle, who's planted that criterion, to see how it works. So go through solutions in depth and try to tell yourself, look, if the question like this appears, how will I tweak it and get to the right answer? And that's very vital. I'm going to stress on those bits when we solve this, because solving a couple of puzzles where, beautifully enough, the first two questions are simple, the next two are trickier, where you need to pick something from them, where you have to say, oh, something here is happening. There is this one criterion unlocks this puzzle. I'm going to stress on that, where you pick that really well. And it turns out, on at least one instance, it's heavily mathematical. So you need to have that slight math quant brain on and switched on during this exam. They're telling us that clearly. DILR stepped away from computation, but it's not stepped away from mathematics. This puzzle we solved last week involved heavy-duty math. You're looking for 150 plus 6K being 7M. I'm trying to solve and see how many solutions are possible. And so math is come back to the fore in DILR, but not in the computation way, but in a logical thinking way. So that's very important to keep that in mind. In terms of how are we going to go to today's session, so DILR is tough to discuss online because you'll see the question and answer on a slide, but you will want to see the question at your own pace. So the questions are shared and available online on our Facebook page group. We're solving questions from CAT 2017 slot 1 paper. Google that, find that out, click that, keep it open. So you can see the question as it was in the exam paper right in front of you. So you can use that and then see the question before we go on to the discussion. Yeah. Fair enough. So do check out the Facebook group to see the question. I'm going to do questions. I'm going to share the screen and then get a start from there. I hope the screen sharing part works really well. This is a part where I don't need to worry about being on the screen and therefore can have some more fun, more freedom to move about. We're going to do this question on rural kids survey. I'm going to read out this question out loud, give you some time, fact on, keep talking that time, give you some time to gather your thoughts and have a go at this, and then we'll discuss a solution. And, a study to look at the early learning of rural kids was carried out in a number of villages spanning 3 states, chosen from the Northeast, the West, and the South. 54-year-old kids each were sampled from each of the 150 villages from Northeast, 250 villages from the West, and 200 villages from the South. And the number here is very interesting. Straight away, we have an instance where we say 50 kids from each village. So from the Northeast, we'll have 50 into 150, 7,500. From the West, we'll have 50 into 250, 12,500. From the South, we'll have 200 into 50, 10,000. These are the kind of numbers that are important to get a sense of what this is. This time spent to making these numbers is very, very useful. So we have 7,500 plus 12,500, 20,000, 30,000 kids being sampled totally. Just found that 30,000 kids surveyed, 55,000 studied in primary schools run by the government, 37% in private schools P, while the remaining 8% did not go to school. 55% of 30,000, so 16,500. 37% of 30,000, so 30,000 into 37 by 100. I know that 37 into 3 is 111, so it is 11,100. Right? The remaining 8% of this is 2,400. This is GPO, government, private, other. How this gets distributed across this, we don't know. That's probably what this puzzle is going to be. So, but when I see numbers, when I see this, before I go to the question and the grid, I like to make sense of each of these numbers. I like to say, look, okay, 55,000 of the total. So I don't know what percentage in any, what percentage in West, what percentage in South this is. But I know the overall way. So the 30,000 is sliced in this manner and in this manner. Cross-slicing is what this set is going to be. I'm already switched on about that. I'm thinking that we're going to come up with a scenario where any gets broken as GPO, and then West gets broken as GPO, South gets broken as GPO. Or we go differently. The government gets broken as any W and S. So we're going to slice and dice this data like that. I love it when I can make sense of the data. I love it when I read this blurb and I say, look, okay, this is what's happening. They're going to come give us data. They've categorized it geography-wise and government public not going to school-wise. So 2 ways. So now I'm going to cross-tab it. That's what this question is likely to be. So make sense of the data. It's very useful. Spend that extra half a minute, 1 minute to say, oh, this is what they're talking about. Now I get this. If you get there, then questions become easier. More importantly, it becomes a compelling data point to decide to go for a question or dump it. Okay. The next one. The kids surveyed were further divided into 2 groups based on whether their mothers dropped out of school before completing primary education or not. The table below gives the number of kids in different type of schools for mothers who dropped out of school before completing. This is for mothers who dropped out. Wonderful. So we've got this entire grid that we had imagined at step 1 We thought GPO classified across any W and S. Any W and S, Northeast, West, and South, classified across GPO is what this data point would be. So getting all this data in. Okay? And we thought we would be filling some of these data points. Turns out our question setters have gone one step better. Then they've said, oh, you think you've got it covered? I'm going to give you a whole different table. So they've given us everything in this grid for one part of the data point for mothers who have dropped out. And so obviously we're going to have an identical kid for mothers who have gone to primary school. This is for mothers who dropped out of school before completing primary education. Mothers who have completed primary education is another table which can be classified in this 3 by 3. That is Northeast, West, and South, G, P, and O. So we've got this whole table handed to us on a platter. We'll have to make sense of the other table. Right? So, but we've already got these numbers at an overall level with us. I don't know if you remember the numbers. It helps to remember the numbers. This was 16,500, 11,100, 2,400. This was 7,500, 12,500, 10,000. Right? So this was 150 into 50, 250 into 50, 200 into 50, 55%, 37%, 8%. I've done this set before, so I'm rattling these numbers off. So don't get intimidated. I have the advantage. Solve this completely, and then I'm sitting here and talking to you. So obviously, I remember the numbers. It'll be a shame if I didn't remember these numbers. Right? So, but if you had made sense of the numbers as and when you see them, then remembering and putting them in place becomes that much easier. So spend that time to make sense of the numbers. So, it is also known that in S, 60% of the surveyed kids were in G. Moreover, in S, all surveyed kids whose mothers had completed primary education were in school. In Northeast, among the O kids, the kids who did not go to school, 50% had mothers who had dropped out before completing primary education. The number of kids in government schools in Northeast was the same as the number of kids in government schools in the West. So what I'm sensing here is we thought we'll get an overall table. Now they've given us one overall table. We fill one more overall table. They've given the kills for mothers not finished primary. If we finish the grid for mothers who finished primary, then we're pretty much going to be done with this question. So that's the idea here. And so these are going to be nuggets and clues to finish this grid. Now, to start with, I don't even want to look at these nuggets and clues because I know that I can fill the total numbers very easily because I know the overall total numbers. And I know that these total numbers have been given to me for mothers who have not finished schools. So mothers who did finish primary school, their total numbers in Northeast, West and South, and in government, private, and O, which is neither, that I can fill in. And once I fill that in, then these clues will probably come into the picture, not before that. The next step for me, these are the questions that follow. As far as the solving part is concerned, I know that this grid has been handed to me on a platter. There's mothers who drop out, GPO, Northeast, West, South on a platter, given. 3 by 3, 9 cells have been filled for me. These are the overall cells. So these are just added up. I add these 3, I'll get this. I add these 3, I'll get this. They are not new cells. Right? Whereas these 9 cells are clearly new information that is handed out. Now, if I can fill one more set of cells like this, then I'm good. Right? Overall, I know that this is 7,500, 12,500, 10,000. 16,500, 11,100, 2,400. 55% of 30,000, 37% of 30,000, 8% of 30,000. 150 villages, 50 students each. 250 villages, 50 students each. 200 villages, 50 students each. Therefore, we can draw this. 7,500 students totally in Northeast. 5,000 have mothers who have dropped out. Remaining 2,500 mothers who have not dropped. 7,300 out of 12,500. So 12,500 mothers totally, of which 7,300 goes off. So we will have 5,200 remaining here. 5,700 out of 10,000 in South, mothers have dropped out. The remaining will be 4,300. Likewise here, the totally 16,500 in government schools. 13,500 are from mothers who have dropped out. Remaining 3,000 are here. The totally 11,100 students in private colleges. 2,700 of those are from mothers who dropped out. Remaining 8,400. This number is 11100 minus 2400. 7, 8, 2,700 subtracted from this, 8,400. Totally 2,400 are in other category. Overall, subtract this 1,800 sitting here, we've got 600. We've got the total numbers for the category where mothers have finished their primary education that we've got. So just as we had thought, we've got these overall numbers. Now remember, if you get these two, you can get this. If you get these two, you can get this. If you get this and this, you can get this. In any row, if you've got two, you've got the third. In any column, you've got two, you've got the third. And so we're not looking for 9 independent cells. You get these two, you get this. Then you get this, you get this. You get this, you get this. And then you can get these two. Probably get 4 pieces. You get everything else done after that. And so let's see if we can crack those pieces. Now we go to the clues sitting there. In South, 60% of the surveyed kids were in G. Moreover, in S, all surveyed kids whose mothers had completed primary education were in school. 60% of the surveyed kids, 10,000 kids surveyed in South totally. 60% were in G. 60% were in government schools. So 6,000 were in government schools. 5,100 are here. This one should be 900. Totally 6,000 from the South are in government schools. 5,100 from mothers who dropped out. So the remaining 900 will be from mothers who completed primary education. And moreover, in as all surveyed kids whose mothers had completed primary education were in school. So in this box, in this column, you should have a 0 sitting there. So mothers who had completed primary education and kids who have not been enrolled in school is 0. So we have filled 2 of these. What can you fill straight away? The total in South, among the mothers who finished primary education is 4,300. This number is 900. It should be 3,400. You get these 2, you get this. You've got an entire row filled. So you get any one, you get one more. You get this, you get this. You get this, you get this. You get 1, you'll get 1 more cell. You get 2, you'll get 2 more cells, and then finish everything up. And so let's see the next piece that's available for us. In Northeast, among the O kids, 50% had mothers who had dropped out before completing. Northeast, among the kids who did not go to school, 50% had mothers who had dropped out before completing. This number is 50% of the total kids who are not going to school. 50% had mothers who had dropped out before completing. That means 50% had mothers who had completed primary education. This is 50%, the remaining should be 50%. This is 300. This wonderful number here should be 300. 50% had mothers who had dropped out. That means the remaining 50% had mothers who had completed their course. So this is 300. This number should be 300. This overall is 600. There's a 300 here. There should be a 300 here. Now we know if you get any one of these remaining 4 cells, you're through. You get this, you can get this. You know this, you can get this. You know this, you can get this. Out of the 4 cells, you crack one piece of the puzzle. You've got the whole grid complete. And now let's go to that. The number of kids in government schools in the Northeast is the same as the number of kids in government schools in the West. This number are equal when you add them up to this number and this number. In Northeast, government kids is equal to government kids in West. Luckily enough for us, these two numbers are equal. That means these two should also be equal. This plus this, government in this box plus government in this box should be equal to government in this box plus government in this box. These two are equal, so these two should be equal. 900 goes off in this. Out of 3000, we've left out 900. We have 2100. That should be split equally, 1050, 1050. And we've got the whole thing on a platter. This is 1050. This is 300. 1350 gone out of 2500. 1150. 1050 and 300. 1350 gone out of 5200. 5200 we subtract 1350. So 50 here. 11 minus 3 is 8. 4 minus 1 is 3. This should be 3850. This is 100, 5000, 3400. These three numbers add up. These three numbers add up. These three add up. These three add up. Everything tallies. We've got two complete tables. We should now just be able to pick up the questions and nail them completely. Okay? This is 1150, 1350. The key here, I can't stress this enough, make sense of the data, the numbers will follow. Makes sense. You should look at it and go. So they're classifying this data into two categories: Northeast, West, and South, government, private, and other, or no school. So I'm going to get a 3 by 3 which I need to fill in. They've broken this 3 by 3 into two categories. So I'm going to fill in two complete tables with 3 by 3 cells, where mothers who have not completed primary education and mothers who have completed primary education. So I'm going to get two boxes of 3 by 3 along with their totals. Once you've got this, then answering questions should be very simple. You've got a complete grid. We just need to pick up the questions and nail them. What percentage of kids from the South were studying in private schools? Kids from the South. Oops, sorry about that. Sorry about that. Kids from the South, that is 10,000 kids, we know that. How many of them were studying in private schools? This 300 plus this 3400 out of 10,000. 3,700 were in private colleges out of 10,000 students overall, or 37%. Very peaceful. Straight away, done. Nailed it. Next one. Among the kids in West whose mothers had completed primary education, mothers completed in West. So out of this 5,200, how many were not in school? 300. Done. Choice A. Among the kids in the West whose mothers had completed primary education, we're looking at this table in West within this 5,200. How many were not in school? 300. Done. If question number 3 and 4 are also this easy, we got it made. Luckily enough, or as expected, that's not going to be the case. This is one of my favorite questions in this bit, and favorite questions overall as well. It's a fabulous mathematical idea sitting here, which is why I said, even though the computation component is out, the mathematical component is not out. And they're definitely asking us questions where math is tested. And so your intuitive ideas about math need to be included brilliantly. And so, in a follow-up survey of the same kids 2 years later, it was found that all the kids were now in school. Super. Brilliant. Starting point, all of these have gone to school. All of these have gone to school. They joined school. Of the kids who were not in school earlier, in one region, 25% were in school now. Fabulous. So either Northeast or West or South, 25% were in school. In the second region, all such kids were in G now. So 25% in one region, 100% in another region. While in the third region, 50% of such kids now joined school, G, while the rest had joined P. 25% were in G, 100% in G, and 50% in G. So Northeast, West, South, from O to G. So it's 25%, 50%, 100%. In some order, mind you, not I'm not saying Northeast had 25% and West had 50% and East had 100%. Three regions, we've had 25% going, 50% going, and 100% going. As a result, in all three regions put together, 50% of the kids who were earlier out of school had joined the G. Fabulous. Fabulous. This is the most important part. Overall, 50% were in G. It is also seen that no surveyed kid had changed schools. Nobody had gone from private to G, G to private. So look at these numbers. The weighted average in some form of 25, 50, and 100 is giving us 50. So think about it very clearly. 25, 50, and 100 weighted average gives us 50. There's something very interesting sitting there. You get that, you nail this question. You don't get that, you're in trouble. And so it is binary. And so think about it like this. Let's break this down. Let's say 25 and 100 combine to give us some weighted average number. And then 25 and 100 give us X. X and 50 in some weightage give us 50. In some weightage. Think about this. What should X be? It's a fabulous idea. You get that, you're walking this question. Right? What should it be? Very simple. Three pots with different weightages give us 50. One of those pots is itself 50. What does that tell us? That 25 and 100 on their weightages should also give us 50. The X should be 50. It's a very interesting idea. You get that, you're walking this question. Very vital, very pivotal. And so 25, 50, and 100 mix in some ratio gives us 50. There is a 50 here in this number that we're looking for. The overall is also 50. One of the components in the weightages and the overall are same. What does that tell us? That means the remaining two should give us weighted average of 50. We're done. We're through. Fabulous. How are we through? Think about this. 25 and 100 mixed in some ratio gives us 50. Combined with this other 50, mixed in any ratio gives us 50. Right? So fabulous. You've got this far, then you're through. Think about this. 25 and 100 will mix to give us 50. In what ratio should we be mixing this? Think about this. 25 and 100 mixed to give us 50. Our famous alligation method gives us a ratio 2:1. So 25% and 100% should be mixed in the ratio 2:1 to give us 50. The remaining 50% gets mixed in any ratio to give us a 50. So now, two of these regions have the total number of students in O in the ratio 2:1. Let's find the total first. Total for Northeast is 300 plus 300, 600. Total for West is 1200 plus 300 plus 1500. Total for South is 300 plus 0, which is 300. Some two of these are in the ratio 2:1. Which two? Only these two. Done. Or the Northeast should have seen a 25% shift. South should have seen a 100% shift. West should have seen a 50% shift. This 25 and 100 mixed in the ratio 2:1 gives us a 50. That 50 with the West remaining 50 gives us a 50 overall. That math insight, that the averages and allegations and mixtures insight has helped us nail this problem. The overall is 50. One of the components is 50. That means the remaining should also be 50. Average of 50 and X is 50. No matter what weightage you average this out, X should be 50. That's all there is to this topic, this question. In some weightage ratio, 50 and X average to give us 50. I don't care what the weightage ratio is, X is 50. So in some weightage ratio, 25 and 100 are mixed to give us 50. What is the ratio? 2:1. What should be 2? 25% should be 2 and 100% should be 1. So 25% of the students in Northeast go from O to G. 50% of the students from West go from O to G. 100% of the students from South go from O to G. Now let's go to the question. Here is What number of surveyed kids were in G in the West? So 25%, 50%, 100%. In the West, the number of students who were already in G is 4200 plus 1050. On top of that, we get 50% of 1200 plus 300. 50% of 1500. 1500 into half, 750 go from O to G. The total people who will be in G, 4200 plus 1050 plus 750. 1800 plus 4200 is 6000. Choice A. Done. Once you've got that 25, 50, 100, you're walking this question. What percentage of the surveyed kids in S whose mothers had dropped out before completing primary education were in G? So effectively, mothers were dropped out. We're looking at this table. In S, what percentage of this number is now this? Remember, 25% went totally, 50% went totally, 100% went totally. 100% means all 300 went here. We had 5100 to start with, plus 300. 5400 are going to be in G in the southern region. We want this as a percentage out of 5700. So 5400 by 5700 into 100. This is a kind of thing that we use a calculator for. 18 by 19 into 100, whatever that turns out to. It turns out it is 94%. You use a calculator and find it out, or you use some simple approximation and get that. So, wonderful set, very doable, very interesting. And so the key part, the first thing you need to get a sense of this, and then say, look, I got one table, and then you say, I've got to get two tables, get the two tables, fill them all in. Then for question 3 and 4, you have to crack that insight. Weighted average of 3 numbers is 50. One of the 3 numbers is 50, bam, go through. The weighted average of the other 2 should be 50. So the other 2 should be in the ratio 2:1, then you get 2. But keep your quant brain, your intuitive numerical brain on. Yesterday we saw, in the last session we saw questions in set theory where some amount of number system reminders, divisibility, that played a role. Here the idea of average mixture, intuitive idea, average mixture, the intuitive idea that's being tested here. Weighted average of 3 entities, 25, 50 and 100 is 50. What is that telling you? That 25 and 100 in some ratio makes to give us a 50. That insight is very critical. Let's go to the next one. It's also a very interesting topic, very interesting thing. I'm going to give you some time to read through the questions, and then we'll jump in and discuss that. So simple happiness index. So go through this for about 3, 4, 5 minutes, and then we'll jump in and try to solve it. Once again, interesting data format. I'm going to give you some time to make sense of this. Then we'll discuss this. As ever, the question in more detailed form is available on our Facebook page, so that you don't have to go across 3 slides, wait for me to click the next slide to read through this question. If you can't land it there, then you can always check out the PDF which is available on the web. Try this out. I'm going to give you some time to read through this, and then we'll discuss this. This again is a good set. I'm going to read this. Simple happiness index of a country is computed on the basis of 3 parameters: social support, freedom to life choices, and corruption perception. So, interesting set. I mean, social support is probably a very interesting metric. Freedom to life choices, again, good. Corruption perception. So if you're done for India, I think we'll rank in the third category. Each of these 3 parameters is measured on a scale of 0 to 8, integers only. We're not dealing with the 6.5 or a 2 pi. A country is then categorized based on the total score obtained by summing the scores of all 3 parameters. That's definitely not all 3 parameters, as shown in the following table. And 0 to 4 is very unhappy, 5 to 8 is unhappy, neutral, happy, very happy. But this is not giving us much. Let's look at the data underlying that. Following diagram depicts the frequency distribution of the scores in S, F, and C, which is social support, freedom, life choices, and corruption perception. 10 countries: A, B, C, D, E, V, W, X, Y, Z. So, Amda, Benga, Kala, Delma, Epa, Parsa, Wana, Zanda, Yanga, and Zuma. A, B, C, D, E, V, W, X, Y, Z. So, the frequency distribution is a very interesting term. What it tells us is 2 countries have got a score of 1 in freedom choice. 1 country has got a score of 1 in freedom. 2 have got a score of 3. 1 has got a score of 4. 3 have got a score of 5. And 1 has got a score of 7. So, you think about it, 2 plus 1, 3, plus 2, 5, plus 1, 6, plus 3, 9, plus 1, 10. 10 countries, all 10 of their scores in F, we've got. And so F scores, if you look at F scores, we've got 1, 1, 2, 3, 3, 4, 5, 5, 5, 7. This is what this diagram means. 2 have got 1, 1 has got a 2, 2 have got 3, 1 has got a 4, 3 have got 5, nobody has got 6 in freedom, that F score, and 1 guy has got a 7. Right? Likewise, if you think about C scores, we've got a 1, 2, 2, 2, 3, 3, 3, 3, a 4, no 5, a 6. And S score, which is the blue bar, no 1s, no 2s, 3, 3, 3, 4, 4, 4, 5, 5, 6, 7. Over here, there are 10 entities in each of those. I'm just trying to make sense of the data. And I'd love to spend an extra minute and a half kind of wrapping this around my head. That time is always well spent. Don't rush through to the question. You need to get this. You need to understand this. And then you're thinking, we need to have a score of 20 to 24 to be happy and to be very happy. Is any country going to be very happy? 20 to 24. We can get a 776. So 776 is possible. So it's a very weird combination. All the top numbers are taken by the same country. Only then will we get a very, very happy. Nobody has got a 0. Nobody has got an 8. All 10 data points are here. The C metrics are very interesting though. The S metrics, S for social support, very interesting. There's no 1 or 2. It starts only from 3. That is very useful. There's lots of numbers at 3, 4, and 5, much lesser in 6 and 7. 1 and 2 somewhere in between. So when I'm making inferences, I should probably make inferences with 6 and 7. I can probably allot those much better. That's the inference I'm drawing. And so 6 and 7 are going to be my starting points when I get to individual scores, not anywhere else. So those are the kind of inferences I would want to think about. Amda and Kala, A and C, jointly have the lowest total score, 7, with identical scores in all the 3 parameters. Zuma has a total score of 17. All the 3 countries which categorize as happy have the highest score in exactly 1 parameter. Fabulous. Fabulous. I love this question. Because the 3 countries that have been categorized as happy, which is a score of 14 to 17, if I'm not mistaken. 14 to 19. Each of them have the highest score in exactly 1 parameter. One has scored high in S, 1 in F, 1 in C. Zuma, who has a score of 17, is one of those 3. So Zuma has also got a score of 17 by scoring the maximum in one of SF or C. AMDA and CALA jointly have the lowest total score of 7 with identical scores in all three parameters. I love this last phrase. That's going to simplify life for us. With identical scores in all three parameters. I'm going to jump in and use that. Total score is 7. You can get a 115 in some order, not choosing the order. And so, or 124 or 133 or 2 2 3 in some order. 115 could be 151 511 115 124 133 223. And so these are the possibilities for this. And so they've got identical scores. You know, 115 115 124 124 133 133 223 223. This should be the scores for AMDA and CALA in some order. And so let's look at this and let's see whether which of these is possible. So I'm going to write these down again here. So I have a 115 115. Is that possible? Can two guys get 115 115? That means there should be 4 ones to start with. It could be 2. Both of them could have got F1 and 1. They don't have room for C1 and C1. And only one guy has got a C1. Nobody has got an S1, Social Security one. So 115 115 is out straight away. 124 124. Is that possible? They could have both got 1 in this box, which is freedom. They could have both got 1 and 2 in this box, which is corruption perception. They would have both got 4 in this box, which is social security. So 124 124 is possible. Brilliant. Right? Let's look at 133 133. They could have both got 1 in F. That is possible. That means in S and C, social support and customer and corruption perception, they should have got 3 1 3 3. Is that possible? So in the orange box, they would have got 1 and 1. So in the blue box, you should have got 3 and 3. In the green box, you should have got 3 and 3. This again is possible. 133 133 is possible. Brilliant. Now let's think about 223 223. So 223 223 both could have got 2s in C, but they cannot have both got 2s in anything else. So this is also out. So AMDA and CALA, A and C, could have added up to 7 in only 2 ways, 124 133. Brilliant. So we've eliminated 2 possibilities. That's that condition, because it says they've got identical scores, is brilliant. We're dealing with either 124 or 133. And so that's very useful. And so the questions here follow from there. As ever, the first 2 questions are directly from the grid. The next 2 have additional questions. This has become a standard pattern. They're basically saying, make sense of this, complete some grid, get 2 answers in the bag, and then do some more work to earn the last 2 points. And that's what our pattern has been so far. So let's see this. So nobody has got an 8 or a 0. I'm going to do a quick recap. Score of 3 is the most frequent. There are 9 instances of 3 out of 30. So if ever we have any constraint, there are ample 3s to give or not. 4 or 5 instances, 5 instances, they are also frequent. Least frequent are our 6s and 7s. Let's look at some of the constraints. You've seen that 115, 124, 133, 223 are possible. Original possibilities. 115 is ruled out, 223 is ruled out. 124 and 133 are possible. In 124, the 1 has to be in the freedom perception. So if we say S, F, and C, 1 has to be here. 2 is the green box here. And therefore, 4 is the blue box here. Or 133, 1 again has to be here, 3 here, 3 here. So for AMDA and CALA, both of them, the possibilities have to be one of these 3. SFC have to be 412 or 313. So fabulous. These are the 2 possibilities. The 1, 2, 4, we can go deeper in that. They should definitely score 1 in the freedom thing. The corruption perception and the social thing, that could be 2 and 4 or 3 each. Those are the 2 possibilities. Fabulous. Now let's go to our Zuma. Zuma has a total score of 17. Now 17, you have to add up to 17. So think about this. 6 plus 6 plus 6 is 18. And so they're very close to averaging 6. And so if you have 1 6, you cannot have 3 5s. 5 5 5 adds up to only 15. And so the highest could be 7 or the highest could be 6. Let's think about both. Highest cannot be 5. Let's say highest is 7. We could have a 7 7 something. 7 7 add up to 14 plus 3. That is one possibility. Or we could have a 7 6 4, 7 5 5 or 6 6 5. And so 7 6 4, 7 5 5, 6 6 5. That's what we're looking at. And so 7 6 4. That means 6 has to be, 7 could be either of these two. 6 could be either of these two. The blue can only be green. If it's an orange, it can be blue or green. So if these are taken, then we come to the 4. That seems possible. 6 6 5. That means both of these are taken, for 6 and 6. That means the 5 has to be the orange one, but orange is available. 6 6 5 is possible. 7 5 5, adding up to 17. We have a 7 here and a 7 here. Both these are taken into account. 7 5 5. One of these two has to be a 7, and then we need to have 5 and 5. Think about this. One of the blue or orange has to be 7, and then we need to have 5 and 5 from the other two. That means the green 5 has to come in. That's not available at all. 7 5 5 is ruled out. You could have thought about a 7 7 3, but a 7 7 would mean 7 in blue and 7 in orange. That means the highest score in both social support and freedom of choice. That's not possible because the highest is from different countries. Each different country has got a different highest. So we need to have room for that. So 7 7 3 is ruled out. 7 5 5 is ruled out because 5s and 7s are both from social support and freedom. So we cannot have a 7 and 2 5s coming from justice. So that's ruled out. So we got a 7 6 4 or a 6 6 5 for Zuma. Now let's get more specific than that. 7 6 4 6 6 5. 6 6 5, life is easy. So 6 6 5, think about S F C. The 6 has to be in C and then S. So the F part should have brought out the 5. That is simple. 7 6 4. The highest could have been in S or in F. Both of these are possible. And then the 6 4. This could have been 6. This could have been 4. Green 6 and F4, orange 4. That is possible. Or a blue 6 and an orange 4. Sorry, blue 6 and a green 4. That's also possible. Both are possible. Fine. So Zuma having 17 could be a 6 5 6 or a 7 dash 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 7 dash. Both seem possible unless we're overlooking something. 7 6 4. S could be 7 or F could be 7. When S is 7, you could have F to be 6 and C to be 4. C is green, there's a green 4 available. F can be 6. There are only 2 6s that both taken. So this cannot be 6. So 7 6 4, this 6 and this 4. Is that possible? With 7 as freedom here. Can we have a 6 here and a 4 here? A blue 6 and a 4 here. Is that possible? Think about it. You have to there is one particular catch I wanted to pick here. If 7 is the highest for Zuma, remember this, then this green 6 has to go to someone else. Right? So then if Zuma has got 7 in S, then the 6 cannot be from green. That should have gone to somebody else. The 6 should not be here. It should be somewhere else. But it's not possible here because F does not have a 6. So this is ruled out. 7 should be here. This should not be a 6. This should be a 6. This should be a 4. If 7 is an F, that means F orange is taken for Zuma. That means this green cannot be the 6 that Zuma has. That means S should be 6 and C should be 4. Or if this were 6, 5, 6, the two 6s are taken and the 5 remaining should be the orange one, F. Now think about this. If Zuma were 6, 7, 4, then Zuma has the highest in this. Somebody else should have the highest as this blue, which is S. The third person who's got the happy should have got this is 6. So this is the highest in F, this is the highest in S, this is the highest in C. 3 different happy countries, each has got highest in S, F and C, which is social support, freedom of choice and corruption perception. The other way around, if you're looking at it from the 656 point of view, then Zuma has got the highest in C. The other two should have got highest in S, which is social support, and in freedom. So the 3 happy countries should stack up like this: 674 for Zuma, and then the 7-006 for the other two, or 656 for Zuma, 7-07- for the other two. What has this got us so far? A and C could be a 124 or a 133. Specifically, it can be a 412 or a 313. Both of them identical scores adding up to 7. Zuma could add up to 656, 17, and 17. The other two countries could have a 7-07- in this criteria, 7-006 in this criteria. 3 happy countries here, 2 at 7. The remaining 5 countries we do not know anything about. This is the broad outline we have got. This we have used the condition that A and C have got 7 with identical score. This we have used the condition that Zuma has got 17. And there are 2 other happy countries, which each of the 3 countries having the maximum in exactly one of the 3 metrics: social support, freedom of choice, and corruption perception. So we got this template so far. Even while reading, you could sense that we're not going to be able to complete the whole grid and just mark down answers. We're going to deal with this and then build from there, from here on. Let's look at the questions. What is AMDA score in F? You need to worry only about AMDA. So we're looking at only the first 2 tables, not the next 2 tables. In F, be it 412 or 313, AMDA score in F is 1 in both cases. Either 412, 412 or 313, 313. We cannot confidently say what is AMDA score in social support or corruption perception. Freedom of choice, both AMDA and CALA, I said A and C, both have got 1 in all our scenarios. So 1, done. What is Zuma score in S, social support? Zuma score could have been 656 or 674 in both cases. In social support, Zuma should have got 6. Wonderful. Our first 2 t-tasks get answered from a threadbare table. Got a threadbare table, 2 possibilities for A and C, 2 possibilities for Zuma and T1, T2. With that, we've answered the first 2 questions. This is the usual way we make sense of the data. We think about what is given. We fill out something based on the criteria, and we put everything in, make some sense, and answer 2 questions. Beyond that, the trickier part starts. Benga and Delma, 2 countries categorized as happy, are tied with the same total score. What is the maximum score they can have? And so what is the maximum score they can have? 14, 15, 16, 17. Let's look at this. look at for maximum scores, we have only totally 2 sevens and 2 sixes applicable. That's it, nothing more than that. Right? So now, if Zuma could have been either this or this, we're dealing with either a table. So, to get to a 17 maximum, we need a 764 and a 665. We know that only these are possible. Our 755 and our 773, they're not even possible. And so 665, if it is taken, then there's no room for a 764. We have a 7, we don't have any more 6s. None of these could be 6s. And so if 764 is taken, we don't have room for a 665. 1 6 is gone, 1 6 is gone. There are no more 6s and 7s available. 17 is ruled out. So 3 countries could not have scored 17. That's ruled out. So we want to look at the maximum. We're looking to carve a solution where there is a 17, 17, 17, or a 17, 16, 16, or a 17, 15, 15. We go step by step. 17, 17, 17 is ruled out. We cannot have that. Now we are going to shoot for 17, 16, 16. And so we're going to think about this with a 6, 5, 6. Now remember, 6s are out straight away. And so we're out of 7s and 6s. So we need to have 5s coming here or 4s and 3s. Right? And we need to have both of these adding up to 16 each. 7 is gone. So we need to have 16 coming up. No 7s, no 6s. 5 plus 4, 5 plus 4. Those are our possibilities. Right? Now think about this. We need a 5 and a 4. And a 5 and a 4. 5 and a 4. Remember, there is no 5 for the green box. So there's no 5 possible here. So both of these should be 4. This should be 5. This should be 5. That's the way we can add up to 16. And so we don't have any 5 for C. C should be 4. C is green. There's only 1 4. So both of these cannot be 4. So with this table, 17, 16, 16 is ruled out. We're going to go to the next table, which is 6, 7, 4. Now let's look for 17, 16, 16. In this table, we have a 7 and a 6. So these two should add up. We're already accounting for 2 7s and 2 6s. Remember, we have only 5s and below to deal with. There's a 7 that has gone here. So a 5 plus 4 will give us a 9 to give us a 16. We're looking for a 16. We need a 5 and 4 here. There's no 5 in C. We have to put a 4 here and a 5 here. Right? No, the 6 is gone here. So these two should add up to 10. This only possibility is 5 plus 5. Run out of 6s and 7s. So do we have enough 5s to accommodate this? So we've already taken a 5 from F. It's already been taken. There are lots of 5s remaining. An extra 5 from F, an extra 5 from S, they're both possible, still remaining. So this grid is entirely possible. 2 7s in the right places, 2 6s in the right places, 2 F5s and 1 S5 possible, 2 C4s, 2 C4s. Is that possible? Oops, we run into trouble there. We have only 1 C4. There we have an issue. We cannot put another C4 here. Green 4 is not available to us. Super. So it looked like 16, 17, 15, 15 were possible. 17, 16, 16 were possible. But that didn't work out either. This is out. This is out. I'm already sensing that this should be possible. I'm going to shoot for 15 being possible. Now let's think about this. 7s are out. 6s are out. We have only 5s and 4s to deal with. For C, 4 is out. These two, now we're shooting for a total of 15. And so 7 is gone. These two should add up to 8. And 4 plus 4 is ruled out. Our best case scenario is a 3 plus 5. F3, C5, not possible. There is no C5. C should be 3, F5. That is possible. These two should add up to 15. So we got a 4 plus 5 or a 5 plus 4. We don't have 6s remaining. Do we have an F5 and an S4? F5, S4, that seems possible. Already straight away it looked like 15 were possible. It looks like 15 is going to be possible. This grid right here. 17, 15, 15 is feasible. We've got that going. 17, 17, 17 is not possible. 17, 16, 16 is not possible. But 17, 15, 15 is possible. It looked like it could be possible because we missed 16 by a very tiny, weeny margin. So straight away it looked like this would be possible. So 17, 15, 15, achieve that here. 17, 15, 15. We had a different possibility. Multiple possibilities are possible for 17, 15, 15. You go to the last question in this. Benga scores 16 and DILR scores 15. What is the maximum number of countries with a score of 13? So 17, 16, 15 accounted for. We already have a 7, 7 accounted for. These three add up to 48. These two add up to 14. We have 62 accounted for. Done and dusted. In the bag. Now, the remaining 5 countries should account for the remaining points. We know that much. Right? So let's add up the total number of points from our beautiful grid here. The total here, totally. Add up the total number here from some nice interesting chart. So this is 3. This is 4 into 2, 8. 3 plus 2, 5 plus 4, 9 into 3, 27. 5 into 4, 20. 5 into 5, 25. 2 into 6, 12. 2 into 7, 14. 26, 51, 71, 98, 101, 109. The total number of points available is 109, of which 62 have been accounted for. 47 remaining of the remaining 5 countries. And so what is the maximum number of countries with a score of 13? We have a 17, 16, 15 in the bag. This end we have a 7 and 7. How many 13s can we have? That's what this question is all about. Now think about this. Remaining 5 countries add up to 47. And so if we had 3 13s, 13, 13, 13, those 3 will add up to 39. The last 2 should add up to 8. Not possible. The minimum score is 7. So 3 13s is ruled out. If you had 2 13s, 13, 13, these 2 account for 26. The remaining 3 should account for 21. That means that should be 7, 7, 7. Not possible. We cannot have 5 countries maxed out at 7, 7, 7. We don't have enough room to accommodate that many 7s. And so even 2 countries with 13 is ruled out. 2 countries at 13, our score will be 17, 16, 15, 13, 13, 7, 7, 7, 7, 7. 5 countries tied at 7. That's not possible. The total just won't add up. With 1, 2, 4s and 1, 3, 3s already accounted for. We don't have enough room to get to the 7. We cannot have 2, 2, 3s. We cannot have so many other countries. Already A and C have identical scores. We put that in, we cannot have 5 countries at 7. So even 2 13s is ruled out. 3 13s is ruled out. 4 13s is not possible, not even a choice. 3 and 2 are ruled out. Effectively saying, can we have 17, 16, 15 and then a 13 in the mix? We can find one country with 13. Maximum number of countries with a score of 13 is 1. If we cannot squeeze in even one country, then we are good. Just say that. Not possible. 0 is the answer. And so we're starting with 2 grids, 17, 16, 15. Could be 6, 5, 6 or 6, 7, 4 for Zuma. Then Benga and Delma have 7, 16 and 15 each. And so we need to fill this out. So let's think about this. If Zuma had 6, 5, 6, we need to have We're out of 7s and 6s. We already know that in both of these scenarios. So if this were 16 and 15, so the remaining two should add up to 9 and 8. So we need to have a 5 plus 4 and a 5 plus 3 in this grid. So let's see if we can fill those numbers in. 5 plus 3 and a 5 plus 4. Remember, C does not have any 5. You already remember that. That's only 1, 4. So it has to be a 3 and 5 and 3 and 4. Okay, so 7 plus 5 plus 3 is 15. 5 plus 7 plus 4 is 16. So 7, 5, 4 and 7, 5, 3. This adds up to 15, this adds up to 16. There's no 5 available with C. Only 1, 4 available. So this is one possibility for getting our total scores of 17, 16, 15. Now, if you can get 113 here, we don't have to even worry about other possibilities for 17, 16, 15. We are through. The total shares are 17, 16, 15. Actually, it should be 17, 15, 16, but that hardly matters. Doesn't really matter. And so 7, 5, 3, 5, 7, 4, adding up to 17, 15, and 16. Zuma, Telma, Benga are accounted for. If you can squeeze in a 13 here, we are good. And remember, no 7s, no 6s. If we need a 13, we need a 5, 5, 3 or a 5, 4, 4. Now, there is no C. There's only 1, 4 for the C. That's already been accounted for here. So we cannot squeeze in a 5, 4, 4. There's no 5. There's only 1, 4. It's got to be 5, 5, 3. With this being 3, these two being 5. If this is possible, we're onto something. If it's not possible, then we have to go back to the drawing board and then figure out different things. 5, 5, 3, is that possible? Are there 3 5s in F? Oh yes, there are. Are there 2 5s in S? Oh yes, there are. Do we have 2 3s in C? Oh yes, we have. Do we have 1 4 in C? Yes, we do. 1 6. Oh, this seems possible. So we could very well have a scenario where Zuma is 656, T1 753, which is in our case it turns out to be Telma. Benga is 574, and then there is one country which has a cumulative score of 13, 553 in SFC. So we could have one country with a cumulative score of 13. We already know that 2 countries and 3 countries is not possible. Maximum number of countries with a score of 13 is 1. It's a scenario where that country has 553, 5 in social support, 5 in freedom, and 3 in corruption perception. The wonderful set. We got to learn about frequency distribution, how to make sense of this data, learn how to work with an incomplete grid, knock off your high numbers with very few 7s and 6s available. So push off those 7s and 6s as early as possible, accommodate them. Keep in mind all possibilities for A and C and Zuma. Then build T1, T2, and T3 based on the constraint. The first 2 questions kind of answer themselves. Third and fourth are trickier because beyond what we filled in the grid, we needed to figure out something. That part is what is a tricky part. So I'm going to go back to our original screen and stop sharing the screen now. So chances are I'm going to be looking at what I am saying right now. I'll have more freedom over where the screen goes. And so wonderful 2 sets, very challenging, very interesting. The first one with the rural thing hinged on that one interesting data point. Second one was a fabulous set because you have to worry about different possibilities adding up to 17, 124, 133, all of that. And so good sets. Do practice DILR. Do start with the CAT 2017 papers. The questions there are brilliantly useful. Do not underestimate them. Go through all 16 sets. They'll define your DILR in a way nobody else can. Right? It's been a longish session. We've gone beyond our point. I didn't want to sacrifice and rush through anything. So sorry about building you back beyond 11 o'clock deadline. Best wishes for CAT. Cheers.